What's up, Eco Nerdlings? Today, we are going to be discussing solar energy. Let's get started.
All right, so there are types of energy resources. About 99% of the energy that we use for heat comes from the sun, and the other 1% comes mostly from burning of fossil fuels. Solar energy indirectly supports wind power, hydropower, and biomass. About 76% of commercial energy that we use, unfortunately, comes from non-renewable fossil fuels such as oil, natural gas, and coal, with the remainder coming from renewable resources. So here are some of the types of resources: non-renewable energy resources and geothermal energy in the Earth's crust. So we have oil and natural gas that's extracted from underground. We have coal, which we have to mine for. We spoke about that in previous podcasts. And we have geothermal energy, which comes from the Earth. So looking at these two pie charts, it's comparing the energy use for the world versus the United States. So looking over here at the world, we have about 82% of the energy world use coming from non-renewable energy. In the United States, 93% of the energy we use comes from non-renewable resources. So we're actually higher than the world average. So most of our non-renewable energy comes from oil, coal, and gas, just like the non-renewable energy for the world. So what we're trying to do is increase right here our renewable energy. So we're going to try and increase the amount of energy that comes from biomass and hydropower, as well as geothermal, solar, wind power. That's kind of where the future is going as far as energy sources. So reducing energy waste and improving energy efficiency. There are 4 widely used devices that waste huge amounts of energy. Those include incandescent light bulbs, probably the ones that I'm looking at right now. 95% is actually lost as heat energy. Then we have internal combustion engines, where 94% of the energy as fuel is wasted. We have nuclear power plants, where 92% of the energy is wasted through nuclear fuel and energy needed for waste management. And then we have coal burning power plants, where about 66% of the energy released by burning coal is actually lost. So there's actually a variety of renewable energy resources that are available, but their use has been hindered by a lack of government support compared to non-renewable fossil fuels and nuclear power. So a lot of that has to do with money, research. Are they going to fund the research? Are they not? Oil industry, all of the politics that go into that are more than you could ever imagine. So some of the renewable energy resources that your generation is going to have to look at in the future will be direct solar energy, the moving of water to produce energy, wind, and geothermal energy. So the European Union actually aims to get about 22% of its electricity from renewable energy by 2010, which has already occurred. Costa Rica actually gets 92% of its energy from renewable resources. So yay, Costa Rica! China aims to get about 10% of its total energy from renewable resources by the year 2020. And in 2004, California got about 12% of its electricity from wind and plans to increase that number to 50% by the year 2020. Denmark now gets 20% of its electrical energy from wind and plans to increase this to 50% by 2030. Brazil gets 20% of its gasoline from sugarcane residue. And in 2004, the world's renewable energy industries actually provided 1.7 million jobs worldwide. So let's talk about solar energy. So what are the different types of solar energy? Well, we have photovoltaic cells. These convert sunlight directly to electricity with about 10% efficiency. And we also have solar thermal systems, where the sun's heat is used to heat large bodies of water, and they produce enough steam that can be used to make electricity. So what type of energy conversions are occurring? Well, we have radiant or heat going to electrical energy, and we're converting heat or mechanical. So what are some of the benefits of this? Well, first of all, it's pollution-free and we have an unlimited source, as long as the sun's still shining. Some of the costs are that it's not useful in cloudy areas or at night, and we don't have enough technology needed to use it very efficiently, but that's starting to change. So here's what producing electricity with solar cells kind of looks like. These are what solar panels look like. Sometimes you might have, at some point in your life, probably seen a solar panel. If you go to high school at Sam Rayburn and I'm your teacher, you should look on the roof because our roof actually has a lot of solar panels because of a grant that was awarded to our school. So these are photovoltaic cells, and those can provide electricity for a house or a building using solar cell roof shingles. So the solar cells can be used in rural villages as well, with ample sunlight, who are not connected to an electrical grid. So you might have actually seen something that looks like this driving by if you're going on a long road trip and you kind of get to a stretch where there's not much around. I know I've actually seen a couple of these set up. So one of the core case studies in this unit is the coming energy efficiency and renewable energy revolution. So is it possible to get electricity from solar cells that convert sunlight to electricity? That can be attached to shingles on a roof, that can be applied to window glass as a coating, or it can be mounted on the racks almost anywhere. So looking at this is an example of passive solar heating. And the heating bill for this energy efficient passive solar radiation office in Colorado is $50 a year. A year. That is insane. $50 a year because of the way this building is set up. So passive solar heating is a system that absorbs and stores heat from the sun directly within a structure without the need for pumps to distribute the heat. We also have active solar heating, and that includes pumps as well as water and everything like that. So passively, we have a direct gain. So looking at this, we have summer sun as well as winter sun. So this building is designed to accommodate the different positions of the sun. Warm air rises and hot air is actually released if it gets a little bit too hot. And the windows are very, very insulated. You can also have a greenhouse or sun space. And here's another example, which is an earth-sheltered one. So you have a triple paned or super windows reinforced by concrete, which is carefully waterproof so you don't have water coming into your house. And then you have a flagstone floor to actually store the heat that comes from the solar energy. So what are some of the advantages versus the disadvantages of passive or active solar heating? Well, first of all, energy is free. The net energy is moderate if it's an active type of solar heating, and the net energy is high if it's going to be a passive type of solar heating. It's very quick installation. We don't have any carbon dioxide emissions. It's very low air and water pollution that occurs. And we also have very low land disturbance if it's built into the roof or a window of a house. And it also is moderate in cost if we're using a passive type of solar energy. So what are the disadvantages? Well, first of all, we're going to need access to the sun about 60% of the time. So if it's in an area where the sun doesn't shine all of the time, or it's cloudy and you're in an area that's constantly raining, that's going to be a problem. If the sun is blocked by other structures, again, that's going to pose a problem in being able to utilize that energy. And we need a heat storage system. There's a very high cost for running an active solar panel. And then the active system also needs a lot of maintenance and repair, so a lot of cost goes into the maintenance and repair of this active system as well. And the active collectors are somewhat unattractive. Well, I hope you learned a little about solar energy. If you'd like to rewatch this video or any others for AP Environmental Science, you can visit my website at www.nerdlingscience.com. Well, this is the Queen Nerdling signing off for today. Stay nerdy till next time.